Hello, my name is Jonathan Apostle, and this is my third lab report for Physics 2211. For the table of contents, Slide 1 was the title, Slide 2 is the table of contents, Slide 3 is the introduction, which includes the purpose, the models, and the fundamental principles, along with a brief overview for the result. Slides 4 and 5 are the main physics ideas, which include an explanation, equations, figures, reasoning for using those equations, along with identifying the system and surroundings. Lines 6 and 7 are the initial conditions of the experiment, slides 8 and 9 are the details of the experiment and the details for the coding, and slides 10 through 11 are the results. Slides 12 through 13 discuss what if and what does it mean questions. An important note is that there are no similarities and differences or sources of error, since there was no physical experimental portion of the lab, also therefore there would be no details for the experiment. The purpose of this lab is to first find the mass of the black hole, and then we will need to find the velocity needed to leave the planet. We can do this by first calculating the perpendicular and parallel components of the net force with the black hole, and then we can determine the initial velocity primarily through trial and error to leave the surface of the planet. The results of this was that after calculating the mass of the black hole, I was able to determine the necessary velocity to exit the planet and go around the black hole. Again, this is all without crashing. Some important equations to know are first, Newton's second law. This shows us that force can be broken into parallel and perpendicular components, and that force is also the rate of change, also called the derivative, of momentum. Again, looking at these parallel and perpendicular components, the parallel one will represent the change in velocity, however, the perpendicular one will represent the change in position. Another equation to look at is the force of gravity. It's important to note in this model, gravity is acting on all the objects. Third off, velocity update formula, this can be utilized for the ship to escape the black hole. When looking at some figures for the systems and surroundings, in part 1, the system is the star while the surroundings is the black hole. And then in part 2, the system is the spaceship and the planet while the surroundings are the black hole. Now looking at my initial conditions for part 1, first I needed to find the mass of the star, which was given to us in the problem. And second off, I needed to find the time in seconds for 1 day. However, for my initial conditions in part 2, first I needed to find the mass of the black hole, which I got from the previous part, and then I needed to have the ship's speed in the x and y directions. This is important to know because I got this simply through trial and error. For part 1, I first needed to find the momentum. I did this by doing the initial momentum and then the final momentum. Afterwards, I could find the change in velocity and also the change in momentum. With this information, I could then find the derivative of momentum, which again was equal to force. After this, I could find the parallel component of the force, and then also the perpendicular component of the force. Now with this, I could find the mass of the black hole. And then I found the average mass by calculating a bunch of masses and then finding the average of all those. After this, I could then find the position. For part 2, my first step was to calculate the gravity on the planet. This includes both the force of the ship on the planet and also the force of the black hole on the planet. Afterwards, I could then find the force of the ship, which again was equal to the force of the black hole and the force on the planet. With this information, I can then use the position update formula, utilizing the velocity which I found through trial and error, to see if I could escape both the planet and the orbit of the black hole without crashing. Now looking at my results for part 1, I was able to first find the net force, which was 9.4 times 10 to the 28th. I could also break this down into the force of the parallel component, which was 8.3 times 10 to the 26 newtons, and the force of the perpendicular component, which was 9.4 times 10 to the 28th newtons. With this information, I could then find the mass of the planet, which was 1.6 times 10 to the 34th kilograms. In part 2, I was able to escape from crashing into both the planet and the black hole. I was also able to get about 1.47 times 10 to the 11th meters away from the event horizon of the black hole. For the what if and what does it mean sections, how are the parallel components of force different from the rate of change in momentum? And this is the same thing, yet they can be calculated very differently. First, for the net force, you will need to calculate the mass of the black hole, and then you can find the force. This is what we did in GlowScript. And then for the rate of change, you would first need to observe the position, and with that you get the velocity, and with that information you get the momentum and then the time, and this can be used to find the rate of change. Now, looking at how can you make the spaceship enter an orbit around the black hole, and you can do this in principle, yet it's extremely complicated. There's a few ways you could tackle this problem, however the one I chose to use was to first off change the position of the spaceship, and then to change the velocity of the spaceship. Now, looking at my GlowScript code and my figure, as we can see the spaceship will start with the same tangential velocity as the planet and in an initial position that is far away from the planet, and this is so it won't crash on the planet. As you can see, it goes around, but it never crashes into the planet or the black hole.